Hello, AP students. This is Mrs. Politsky, and I have notes for Chapter 6, Learning. We're going to talk about classical conditioning. So, what sort of learning does classical conditioning explain? Well, Ivan Pavlov, who lived from 1849 to 1936, would have been insulted if you had called him a psychologist. His experiments on salivation, which is the first step to digestion, went to array. Got to remember he was a physiologist, not a psychologist, but it sent Pavlov and his crew on a detour into the psychology of learning. And the problem that he was facing is that the animals in his lab began salivating before he gave them their food. From what the story says, is that Pavlov was working with his subjects, these dogs, and they were putting like what it would basically be a powdered form of meat out for these animals. And over time, the animals began to anticipate when the food was going to arrive. So when they saw or they would hear the lab assistant either walking down the hall or maybe the jingling of their keys as they entered the lab, they just assumed that they were going to get some food. And he had stumbled upon an objective model of learning, one that could be manipulated in the lab to tease out the learned connections among a stimulus and a response. And this discovery is now known as classical conditioning. And classical conditioning is a basic form of learning in which a stimulus produces a innate reflex that becomes associated with a previously neutral stimulus, which then acquires the power to elicit some kind of response. So as we go along, we're going to kind of break down some of these different classical conditioning models. We're going to talk a little bit about Pavlov's dogs here in a little bit, and a little bit about little Albert. But breaking it down into things like unconditioned stimulus, unconditioned response, a neutral stimulus, a conditioned stimulus, and eventually a conditioned response is all part of the essential elements of classical conditioning. So, Pavlov's work on learning focused on the automatic responses known as reflexes. Reflexes, they are normally triggered by a stimulus that have a biological significance. So, we could do an experiment that we could actually basically condition a person to have their eyes dilate on the command of maybe a bell. Okay, because the way our eyes dilate is really kind of a natural reflex. I mean, as far as being exposed to darkness in an environment, your eyes typically do dilate. So Pavlov's great discovery was that the reflexive responses could be associated with a new stimuli, hence a neutral stimuli that had previously produced no response whatsoever. So first, they had placed an untrained dog in a harness, and they set up a vial in the animal's mouth to capture the saliva. Then at intervals, a tone would be sounded, and after the dog was given a little bit of the meat powder or the food, gradually over a number of trials, the dog began to salivate in response to the tone alone. So the neutral stimulus is any stimulus that produces no conditioned response prior to learning. And in this case, that is our tone, the sound. And when it is brought into a conditioned stimulus, meaning that it gets paired together, the assumption is that the same condition occurs even after one pairing of the conditioned stimulus and unconditioned stimulus. So when paired with a neutral reflex, this produces a stimulus, hence the food, will itself begin to elicit a learned response to salivation that's similar to the original reflex. So to break this down, to kind of get a better idea of this, we have our food, our unconditioned stimulus, and the dog's unconditioned response, which would be salivating on command. As we are presenting things, we could prevent the neutral stimulus alone, and it would probably have no uh, innate or reflexive reaction to the dog, so there's going to be no salivating. But once we pair the food and the neutral stimulus, be it the tone and the food together, we're going to get an unconditioned response. That's going to be the salivating. And if we continue to do that over many pairings, so over several presentations of this neutral stimulus and unconditioned stimulus, we're going to get the unconditioned response. At some point in time, we can remove the unconditioned stimulus and get a conditioned stimulus, just the tone alone, getting a conditioned response to salivating. All right, so acquisition. In classical conditioning, what does this involve? The unconditioned stimulus, this is the stimulus that elicits the unconditioned response, the stimulus that automatically, without conditioning, provokes a reflective response. The food in Pavlov's experiment was the unconditioned stimulus because it produced salivation, and this response is called the unconditioned response, or the UCR. And the response is that elicits an unconditioned stimulus without prior learning. The unconditioned stimulus and the unconditioned response involves no learning. Okay, during acquisition or the initial learning stage of classical conditioning, this whole idea of the presentation of our unconditioned stimulus and the neutral stimulus, be it the tone, we are going to eventually, after a series of trials, the neutral stimulus is gradually going to elicit the same response as the unconditioned stimulus. So in other words, the tone alone, that neutral stimulus, is eventually going to be just like the food, and it's going to cause that animal to go ahead and salivate. So acquisition, this is the initial learning stage in classical conditioning, during which the conditioned response comes to be elicited by the conditioned stimulus. So if you take a look kind of as a graphic as far as how we're going to learn this, at first when you have the presentation of the neutral stimulus, if it's not presented or paired up with the unconditioned stimulus, the food, you're not going to get much of a reaction. But as you pair those several times together, eventually the dog is going to learn that they're going to get food and they're going to salivate. And so, they're going to learn that very quickly. But once we remove the food, okay, and we just have the neutral stimulus, which now becomes the conditioned stimulus, and that always happens. Neutral stimulus always becomes the conditioned stimulus. That alone, for a very, very short period of time, is going to make the dog salivate. They're going to figure it out pretty quick. And eventually, they're going to stop salivating. If you wait a period of time, and this is where we get into this period called extinction, you could bring back the tone, and eventually the dog is going to salivate, showing that they have learned how to do this. So, conditioned stimulus, or the CS, in classical conditioning, a previously neutral stimulus that comes to elicit a conditioned response. Customarily in classical conditioning, the neutral stimulus is called the conditioned stimulus when it's first paired with the unconditioned stimulus, or the UCS. Moving on, the conditioned response, or the CR, in classical conditioning, is a conditioned response elicited by previously neutral stimulus that has been associated with the unconditioned stimulus. So timing is critical. The conditioned stimulus and the unconditioned stimulus must be presented continuously, closer in a period of time as the organism can make an appropriate connection. The range of time intervals between the conditioned stimulus and the unconditioned stimulus will produce the best conditioning. Depends on the response being conditioned. All right. Extinction and spontaneous recovery. So, extinction in classical conditioning is the weakening of the conditioned response in the absence of the unconditioned stimulus. So, in the case of Pavlov's dog, the conditioned response is our salivating, and the unconditioned stimulus is our food. Over a period of time, if the food disappears, the dog's going to figure that out. So, spontaneous recovery is the reappearance of the extinguished conditioned response to salivating after a time delay. And so it could be several days or several presentations. So, the conditioned salivation response in Pavlov's dogs were easily eliminated by withdrawing or withholding the unconditioned stimulus, the food, over several trials in which the conditioned stimulus, the tone, is presented alone. Extinction is what occurs, and that occurs when the conditioned response is eliminated by repeated presentations of the conditioned stimulus, the tone, without the unconditioned stimulus, the food. Spontaneous recovery occurs when the conditioned response nearly always reappears at the same or a lower intensity. The occurrence of spontaneous recovery is of considerable importance in the behavior modification therapy for fears, but spontaneous recovery has theoretical importance as well. It tells us that extinction does not involve the complete elimination of the response from the organism's behavior repertoire. So extinction suppresses the conditioned response. All right, generalization. Stimulus generalization, this is the extinction of a learned response to a stimuli that are similar to the conditioned stimulus. So, when we get into talking about baby Albert, we're going to kind of focus on this a little bit more, but it could be changing the sound of the tone as we are presenting the food. So rather than ringing a bell, maybe we sound a buzzer. Anyway, Pavlov demonstrated this by showing that well-trained dogs would salivate in response to a bell that made a slightly different sound than the one that he had used during the conditioning. Discrimination learning is or stimulus discrimination. This is a change in responses to one stimuli, but not to stimuli that are similar. So opposite of stimulus generalization. So Pavlov and his students demonstrated this experimentally when they taught the dogs to distinguish between two different frequencies of tones. Conditioning and experimental neurosis. Pavlov, one stimulus was always paired with food, the other was always paired with a painful electric shock. Pavlov gradually changed the ellipses to become more and more circular, and as a result, discrimination became increasingly difficult, and the dog's response grew more erratic. Hence, we have our experimental neurosis. This is a pattern of erratic behavior resulting from a demanding discrimination learning task, typically one that involves aversive stimuli. All right, the notorious case of little Albert. John B. Watson and Rosalie Rayner, probably almost 90 years ago, in the experiment that they conditioned an infant, in this case, the infant named Albert, who you see pictured below, to react fearfully to a white lab rat. And they conditioned the fear repeatedly by presenting the rat paired with an aversive unconditioned stimulus, or the loud sound of a steel bar struck by a mallet. It took only 7 trials for little Albert to react with fear at the appearance of the rat alone, or our conditioned stimulus. Watson and Rayner then showed that his fear readily generalized from a rat to other white or furry objects, such as a Santa Claus mask and a fur coat worn by Watson. The experiment caused Albert only temporary distress because his fear extinguished rapidly. Thus, the fear had to be strengthened. And this need to recondition Albert threatened the whole experiment when, after 5 days, Watson and Rayner were attempting to show the child's fear could be generalized to a dog and a rabbit and a seal's coat. Watson decided to freshen the reaction to the rat by striking a steel bar, and the noise startled the dog, which began to bark at little Albert. And this frightened not only little Albert, but it frightened Watson and Rayner. So, this is kind of an experiment that kind of went awry a little bit. To break down this experiment, you got to talk about the neutral stimulus. That's our rat. Albert initially was not, I guess you could say, impressed by it. There was no response. The unconditioned stimulus, that would be our loud sound, that would elicit a response, the unconditioned response, which would be crying. As we pair the sound, the unconditioned stimulus, with the neutral stimulus, our white rat, that alone would make the unconditioned response appear. So Albert would begin to cry. And at some point in time, just the presentation of this neutral stimulus, which becomes the conditioned stimulus, the rat, elicits the conditioned response. Just seeing the rat will make him cry. So World War II sailors who were exposed to the signal calling them to battle stations, the sound was strongly associated with danger. This would be a conditioned stimulus for an emotional arousal. And the persistent effect of this learning was shown in a study conducted 15 years after the war, when Navy veterans who experienced combat still gave a strong automatic reaction to the old call to battle stations. Mary Cover Jones, who you see pictured below, in 1924, basically studied the unconditioned the fear of a 2-year-old subject named Peter towards a white rabbit and a white lab rat. Through a series of sessions in which she increased the degrees of toleration, the fear began to decrease until at the end that Peter stated that he liked the rabbit. And a good therapeutic strategy combines extinction of a conditioned fear response and with learning a relaxation response to a conditioned stimulus. And this now becomes kind of the model of what we call counter conditioning therapy, that teaches patients to respond in a relaxed manner to some kind of conditioned stimulus. So down here in the bottom right-hand corner is kind of a breakdown of Mary Cover Jones's experiment. The conditioned stimulus is our white rat or white rabbit that obviously kind of bothered Peter. But when we pair it up with something else, like our unconditioned stimulus, be it some milk and cookies, the unconditioned response obviously makes Peter happy. We pair the rabbit or the rat with the presentation of the cookies and milk, and over time, the unconditioned response is going to be happiness. And then eventually we'd leave the cookies out and just present the rat or the rabbit, and the conditioned response is obviously Peter is not bothered by it. So conditioned food aversions, this is when we've had bad experiences with food that has made us ill. The taste and smell or appearance of specific foods is enough to cause a feeling of nausea for some people. Learning to avoid foods associated with illness has been a survival technique for most people. John Garcia and Robert Colling first recognized the selective conditioned stimulus / unconditioned stimulus connection when they noticed that rats avoided drinking water from bottles in chambers they had previously been made nauseated by radiation. And so if you take a look below, we've got our rat. His conditioned stimulus is our water. The radiation is your unconditioned stimulus, and the nausea is the conditioned response. So in 1966, they found that rats steadily learned an association between flavored water and illness, and yet the rats could not be conditioned to associate flavored water with an electric shock. So, a challenge to Pavlov. Oh, there it is. Breaking down the study here. So we have kind of the conditioned stimulus, the loud noise, unconditioned stimulus, the shock, the fear response. Loud noise, radiation is our unconditioned stimulus, but nothing is learned. Sweet water and a shock, nothing is learned. But then when we present the sweet water and the unconditioned stimulus, which is our radiation, the nausea, then they would avoid the water. So, challenges to Pavlov. Taste aversion learning. This is a biological tendency in which an organism learns after a single experience to avoid food with a certain taste if eating it is followed by an illness. So if you've ever had, let's say, the stomach flu and you ate something and then you got sick immediately after that, there's a tendency to avoid certain foods that have made us nauseous. Anyway, food aversions can develop when the time interval between eating and the illness extends over several hours compared to just a few seconds in Pavlov's experiment. So that taste aversion kind of lasts for a long period of time. John Garcia, again, is going to kind of test this theory of food aversion. And he and his colleagues demonstrated how averse conditioning can dissuade wild coyotes from attacking sheep. And the researchers did so by wrapping toxic lamb burgers in sheepskins and stashing them on sheep ranches out in Wyoming. And when the roaming coyotes found and ate these morsels, they became sick and developed a distaste or an aversion for lamb meat. And in the end, they were able to reduce the attacks on these sheep by 30 to roughly 50%, which is pretty amazing. Anyway, the conditioning involves both nature and nurture. Conditioning depends not only on the learned relationship among the stimuli and the response, but also on the way an organism is genetically attuned to certain stimuli in their environment. Thank you very much.